Welcome again to Number Sense Academy, and today, or in this video, we're going to look at graphing systems of linear equations. So we're actually going to go through a set of examples and put them on the Cartesian plane and see what kind of solutions we get. So tricky thing with graphing when you're not using technology, it won't be perfect. It might not even be accurate. It's more of an approximation, but I'm going to emphasize at least trying to make sure your plane is scaled. That's why I went and got a scale here that I'm going to be using. And then unlike when we just try to, get a couple points and then graph the line and then move on, we're going to have to be a little bit more diligent with trying to make sure our line is as accurate as possible. So this already presents its own challenge, but we can work through it. Again, once we try and make sure we're as detailed as possible with our graphing, then we can get as close to the answers. In another video, we're going to look at how you actually get the actual answer just by using different methods to find a solution to a system. But for now, we just simply want a visual representation so we get an idea as to what the solution is, can be, and then we move on from there. So if I have this example, x is equal to negative 2y, so that's my first equation. And then my other equation is y is equal to 3. Okay, let's see what these look like. So what I'm going to do, I'm going to graph the easier line first. I'm going to start with y equals 3 because we know that it's just a horizontal line going through the y-intercept of 3. So I'm going to find that point. I'm going to draw a horizontal line parallel to the x-axis going through that point. And of course, it's going to look sloppy. And then I'm going to go and graph x equals negative 2y. Now, this is written in terms of x, but because there's a value, or because we have the y here, we know it's not just an undefined line. So we're going to rearrange this so it looks like negative 2y equals x, and then I'll solve for 2y by dividing 2 on both sides, or negative 2 on both sides. I end up with negative 1/2 x. So this is what I'm going to use. I'm going to use this to put on the line. So there's no intercept showing, so it's automatically 0. All right, this is still of this equation y equals negative 1/2 x. It's still of the form y equals mx plus b. It's just that there's no b, which means that b is 0. So the y-intercept is at the origin. So we know that we're going rise over run is negative 1 over 2. So that means we go down 1 and to the right 2. Or we can go 3 or 2 to the left and then up 1. And that'll keep the line going in the direction that we need it to go. So we need the line to go this way. So because we need the line to go this way, we know that if we go to the left and up, we're getting the same result. So let's do that. So we're going to go to the left 2 and up 1. And I'll show you what I mean. So if I go down 1, because the negative 1 says go down, it's going to go down 1 and to the right, I'm going to get this point. So if I follow this pattern, that means I'm going to go to the left 2, up 1. To the left 2, up 1. So we're going to go to the left 2 and up 1. To the left 2 and up 1. So what you see here is that because we spend the extra effort to graph this or find these points, we get something that's more accurate. So this is going to be y equals negative 1/2 x. So here we find our point of intersection. And that looks like it's about 3 and 6. So our solution to this is, so it's not 3 and 6. It's negative 6 and 3. Okay. So let's look at another example. So we have x plus y equals 5. And then we have x minus y equals 3. Okay, so I think the easiest way to get these ones on the graph is to we're going to use the x and y intercepts. So for the first one, when y equals 0, x is equal to 5. Just plug them in and you'll see. And when x equals 0, y is also equal to 5. So that's pretty straightforward. So we find those. So we need 0 and 5, and 5 and 0. So just to reiterate, so our point from here would be 5 and 0, and our point from here is 0 and 5. And then we could connect these. Again, I got to try and hopefully they're scaled well where we could see what's actually going on. Might have to redraw it. So again, we're going to use the same principle for this one. So we're going to, when y is equal to 0, x is equal to 3, and when x is equal to 0, you're going to find that if you solve the equation, because you're going to bring, we're going to have a negative y is equal to 3, so that means that y is equal to negative 3. Right, so our first point is going to be 3, 0, and our second point is going to be 0, negative 3. So we'll find those. So 0, negative 3 is right here, and then 3, 0 is right here. So if we connect those, so I want you to watch what, so if I drawn this properly, and I can't zoom, if I drawn this properly, then it would have went through actually this point. So I think it looks like the solution to the system is going to be 4 and 1. So that's the point where they intersect. Cool. All right, next example. Now we have x minus 2 is equal to 0, and we have 2x plus 3 equals 0. All right, so you should recognize these equations. So when I solve, I'm going to get x is equal to minus 2 here. And when I solve for x here, I'm going to get 2x is equal to negative 3, which means x is equal to negative 3 over 2. There's no y values, no y parameter, if you want to call it that, no y value. Or no, yeah. So the only y value we'll get is, where is that y is equal to, we have, sorry, I'm mumbling. So x equals 2 lands right here, and that's just a vertical line. It's supposed to be nice and parallel, sitting on the axis, but I can't draw properly, so I apologize. Okay, so when I was saying there was no y values, it's not that there's no y values. Like we can find points on this line where x is equal to 2. Like this is a point on this line, 2 and 6, and then this is another point, 2 and negative 6. But everything is going to be, x is equal to 2, always. X equal negative 3 over 2. So negative 3 over 2 is about 1.5. So it's about here. If you run that, that's also a vertical line if you draw it properly. All right, so this is x is equal to negative 3 over 2. Okay, well, these are parallel lines. What does that mean? No solution. Okay, with parallel lines, there are no solutions. Next example, we have x is equal to 2y minus 1. And then we have x minus y is equal to 4. So x is equal to 2y minus 1. Let's solve this for y. So we get 2y minus 1 equals x. Then I have 2y is equal to x plus 1. Divide everything by 2. So I have y is equal to 1/2 x plus 1/2. Okay, so let's graph this one. So we have a y-intercept of 1/2. So that's going to be right here. 1/2. And then we're going to rise 1, run 2. Rise 1, run 2. Rise 1, run 2. And this way you got to be a little bit careful because now you're stepping in the middle of the scaled points. So it's be a little bit tricky because we're starting at 1/2 and we got to go 1 above. So we're going to go here, then we're going to run 2, up, run 2, up, run 2, up, run 2. And this is where scaling, when if you don't draw your graph properly, it's really messy. Oh my goodness, I messed with my line. Okay, so let me redraw that. Back. Y is equal to 1/2 x plus 1/2. All right, and then the next line, we have x minus y is equal to 4. So we're going to use the x-intercepts. So when x is, or x and y intercepts, so when x is 0, y is equal to negative 4. And you could check. And then when y is 0, x is equal to 4. So when x is 0, y is equal to negative 4. 0, negative 4 is right here. And then when y is 0, x equals 4. So that is right here. So now we got to connect these two. And I might have either hit that by luck or forced it where it's here, or it could be over here, really and truly. If I push this line properly, yeah, it's probably over here. So the points are, so this is going to be 4.5, y is going to be 4.5, and x is going to be 8. So that's the solution. 8 and 4.5. Let me make this look a bit better. 8 and 4.5. So that's the solution. I think it's closer. I don't think it's 7 and 4 because the curve is pretty poorly drawn. All right. Next example. We have y plus 3 equals, no, sorry. X plus y equals 3. And then we have 2x plus 2y plus 6 equals 0. So this one's going to take a bit of work. Right away, I see that I have a 2, and a 6. These are all even numbers. So I could reduce this equation by dividing everything by 2. When I say reduce, I mean reduce to a lower term. Okay, everything divided by 2, I'm going to end up with x plus y plus 6, plus 3, sorry, equals 0, which means x plus y equals negative 3. And then we could figure out what to do from here. So we have x plus y equals 3, and then we have x plus y equals negative 3. So let's solve. So when x is equal to 0 here, y is equal to 3. And when y is equal to 0, x is equal to 3. So let's put that on the graph. X is 0, y is 3. boom, y is 0, x is 3, right there. We'll connect. And this is x plus y equals 3. And then for here, I'm just going to move the calculation over to the right. So when x is 0, y equals negative 3. And then y is equal to 0, x is equal to negative 3. So 0, negative 3, boom. And then when y is 0, x is equal to negative 3. All right, so we connect these. And there you go. So these look like parallel lines. And we can just do a quick check. So x plus y is equal to 3. So that means that y is equal to negative x plus 3. Then we have x plus y is equal to negative 3. That means that y is equal to x minus 3. No, negative x minus 3. Oops. Oopsies. So y is equal to negative x minus 3. Yes, both their slope is negative 1. So they are parallel lines, which means, again, no solution to this system. All right, keep us going. So now we have y minus 3x minus 5 equals 0. And then we have 3y minus 9x plus 2 equals 0. So this becomes y is equal to 3x plus 5. And by now I'm assuming you're really good at solving these equations. So we're just isolating for y. So here I have 3y equals 9x minus 2. And then y is equal to 3x minus 2 over 3. Okay, so this one's going to be a little bit tricky to graph just because of this 2 over 3. But we'll figure it out. So let's do this one first. We'll do this one first. And so 3x, we have m is equal to 3 over 1. And we have b is equal to 5. So we have there. Then we're going to rise 3 over 1. 1, 2, 3 over 1. This is going to run off my graph, so let me get some points before this. So if I'm running 1, then I could go back 1 and down 3. So that'll take me to 2. Back 1, down 3. That'll take me to negative 1. And then all the way up. And just so I know which graph is which, 3x plus 5. And then for this one, I need to find minus 2 over 3, which would be 2/3 is about here. Let me put that in green. 2/3 is about here, right? Best as we can. And then now we got to go up 3 across 1. Up 3 across 1. So let's see if this works. This looks kind of... yeah. Okay. So up 3. 1, 2, 3 across 1. 1, 2, 3 across 1. 1, 2, 3 across 1. All right. So we already see what's happening here again. These lines don't look like they're trying to meet. And we already know why. And you could have guessed without even graphing this thing. We just wanted a visual. So m equals 3, m equals 3. Parallel lines, no solution. So there's your tip. Before you even start graphing, look if the slopes are parallel or the slopes are equal. So if the slopes are equal, they're parallel, then you could already say there's no solution. The only way you graph it is to just double check. Our next equation, we have 4x equals negative 5y, and then we have 2x plus y equals 6. So let's start with this first equation. So we want to get y by itself. Negative 5y equals 4x. So y is equal to 4, or over negative 5x. Same thing as negative 4 over 5 is 4 over negative 5, which is equal to negative 4 over 5. It's a negative quotient. So y is equal to 4 over 5x. So because there's no b, that means this goes through the origin. And now we got to rise 4, then run 5 in the negative direction. So that means that we go 1, 2, 3, 1, 2, 3, 4, and then go back this way, all the way to negative 5. Right? So that's what this is saying. This one is saying rise 4 and then to the left 5. This one is saying go down 4 and then to the right 5. This one is saying the same thing as these. Okay? So that means I could come up with another point. I could go down 4, right? I'm going to go down 4 and then to the right 5, and I have my point. Make it nice and long. Y is equal to negative 4 over 5x. And then 2x plus y equals 6. Again, I'm going to take the shortcut and use the intercepts. So when x equals 0, I have 2 times 0 plus y. So y is equal to 6. And when y is equal to 0, I'm going to end up with 2x is equal to 6. So x is equal to 3. And then I'm going to find those points. So 0, 6. So x is 0, y is 6. Right here. And then when x is 3, y is 0. So right here. So I'm going to graph these. And as you can see, I've gotten sloppier and sloppier with these equations. So y, 2x plus y equals 6. All right, so if I had graphed this properly, I'd probably end up with this point somewhere here. So I'm going to say that there is a solution. I don't think I've been noting that. So it's a unique solution because they cross each other at one point. And I'm going to say that the solution is about 5, 4. It's negative 4. 5, negative 4. And I'm not going to do this here because we do have other videos that show you how to find these. Actually, no. No. I feel like I'm rambling. So we could just check that 5, negative 4 fits any one of these equations. So let's see. We have 4x is equal to negative 5y. Let's just sub these values in and see what we get. So where x is, we're going to put 5. And where y is, we're going to put negative 4. And lo and behold, 20 is equal to 20. So as poor as our graph was, we guessed the correct answer. Okay, and it works. If this answer was off, then we'd say, okay, maybe we need to change one of the points to something that makes more sense. All right, and now we have x minus 3 equals 0, and we have x plus y equals 3. So x is equal to 3. Let's find that. We know it's just a vertical line through x equals 3. Just x equals 3. And then here we have y We have a slope of 1, y-intercept of 3. So we could just find the intercepts for both. And we've done this a couple times now. So we have when x equals 0, y is equal to 3. When y is equal to 0, x is equal to 3. So we're going to go find 0, 3, and 3, 0, which is right here. Okay, so this is x plus y equals 3. And right there, we found the intercept. So this is a unique solution. And that solution takes place where x and y are 3 and 0. Okay? And that is all.